Suppose you are a manager in charge of analytics at a medium-sized business. You have been working on a major data science project for the past 18 months and have finally delivered a successful analytics tool last quarter, and it is being used to help the company make important decisions. One day your boss walks in and congratulates you on a job well done before making one request. She needs to know how much this new decision-making tool adds to your company's bottom line. You are stumped by this request because you don't even know where to start. Do you build a new analytics tool to measure how effective this one was? And how do you measure whether that analysis is doing a good job of measuring your analytics system? This video from Aluma Vera will go into some strategies for how to measure the success of advanced analytics tools. Say, for example, that the data science tool that was built manages the inventory your business requires to make sure that all customer orders are fulfilled while minimizing the cost of inventory on hand. This requires a demand planning forecast as well as optimization models to decide how many units of each of the inputs to order, as well as what products capital and labor should be spending their resources to make. The model is complicated, and your boss is essentially asking you to examine one thing. What is the difference in profits between the company having this tool make decisions for the business and having no tool at all? The difficulty with this type of problem is that you can only see one of those two scenarios come to pass. The world we live in includes the analytical tool making purchasing decisions for the company, while the other scenario, where no tool exists, is purely hypothetical. This hypothetical alternate scenario that we cannot observe is known in analytics as a, quote, counterfactual. Think of it like an alternate universe where no analytics tool was built. This inability to view the world two different ways is a central issue in the statistics field of causal modeling. There are many options one could use to attempt to handle these types of situations. We will explore three here. One possibility would be comparing the time period immediately prior to implementation of the tool and the time period immediately afterwards to see what the impact on the metric of interest was. While this seems like an easy and obvious solution, typically one makes very large assumptions when doing this type of analysis. Other events that may impact the bottom line could have occurred at around the same time as the launch of the new tool, such as a change in the regulatory environment, a separate department may have changed to a different supplier who operates on a different timeline, or a change in pricing of raw materials could all confound the measurement of the tool's effectiveness. Another possible solution would be to conduct what is known as an A/B test. This is a commonly used method of evaluation in web design, where some visitors to the website are randomly selected to see one experience, while the rest see a different one. In this test, when enough data is collected, the two website experiences are compared in terms of the metric of interest to see if there is a statistically significant difference and which experience performed better. This is an ideal type of test for you to run in order to do this evaluation because it is akin to a randomized experiment. However, most circumstances do not allow for such an analysis because it requires the ability to randomly divide the data into a treatment and a control group, which is not possible for most measurements. A third option would be to use the tool itself to determine how effective it is. The way you would conduct this test would be to use the tool to estimate the profitability of two different scenarios. The first scenario is the one where the tool makes the decisions on inventory control and purchasing. The second scenario would be the purchasing and inventory controls you would have implemented had the tool not been available. You would then compare the profitability of each scenario to see how effective the tool is. This method requires you to know what the status quo would have been had the tool not been available. While this method can work to some degree, the system contains an optimization that will always tell you it is giving you the best possible solution, so it always thinks it is a really great product, even if it has flaws that could be serious. There is no solution that will necessarily work well in all cases. Professional data scientists can help determine which of the solutions discussed might be a good fit for measuring the value of your analytics. They can also help design a custom solution for measurement. If your business uses analytics tools and needs help determining their value, Aluma Vera can help. The experts at Aluma Vera have a combined over 30 years of experience building data science tools and analyzing their value. Please reach out to us at www.ilumavera.com to schedule a consultation.